Hello everybody, this is Cameron Snow with Danomics.com. In this video, we're going to be continuing along with our Danomics Decline Curve Analysis series. What we're going to cover in this video is how you can make multi-well type curves in Danomics. So in our previous video, what we had done is we had gone through, we created a project, we filtered down to our Niobrara wells that are greater than 1 mile lateral, drilled after 2010, and we uh, went through and we did an automated decline, set some constraints on that, and then updated that with a manual interpretation. In this video, what we're going to cover are those multi-well type curves. So to make a multi-well type curve in Danomics, what we do is we come here to our type curve module, and first thing we need to do is we need to add a type curve. So I'm going to create one here for the Niobrara, and I'm going to create a Niobrara average type curve. So I'm just going to call that Niobrara average. And the first step in this is we need to select the wells that we want to work on here. So I'm going to create a new well set, and I'm going to call this Niobrara average. And we're going to start off, we're going to select by formation, of course, the number of filters that we can use here. I just want to highlight a couple of them to you. So we're going to say wells that are spud after 2015. And let's say we also want to make sure that we've got, cum oil, let's say greater than 5,000 barrels. So, let's make sure we don't have any wells in there that, hardly have any production at all. So let's grab that well set, send it over to our the set that we're going to use, and hit OK. And once we do this, this is where our starting view here. So we can see we've got our oil and gas phases here. We're going to add a few things here. So we're going to add water, and we're also going to add well count. So well count's crucial when we're doing this type of analysis. And let's put this on log scale. That seems to be a better way to look at it. And let's also split the scales here. So we're going to stagger our fluids. All right, so now what are we looking at here? So we've got curves for oil, gas, and water shown in blue, red, and green respectively, and we've got our well count here shown in the dark blue. And it tells us we're looking at 103 wells. And what it is we're looking at is the average. Okay, so let's see. How do we want to view this? Well, I want to see the individual curves here. So I'm going to say show individual curves. And now that I do that, now I can see the curve data that's actually gone into building that average curve that we made. All right, and I'm going to make this a bit bigger so we can clearly see things here. And the first thing I want to do is I want to make my type curve for oil here. So a couple ways we can do this. I'm going to drag and drop. So I'm just going to grab this here, and then I'll grab my endpoint and I'll move it, just somewhere out here. I just want to go through my data here, and once again, I'll just work on this curve a little bit until I get the decline that I want on it here. All right. And one thing that's important to pay attention to here is the well count. So we see the well count here. We start off with around 100 wells, 103 actually, and we see that after about 3 or 4 years, we're down to about half that number. I want to make sure I've got, let's say, 20 wells here in my set. So I'm really only going to concentrate on the data that's here in the first half of my decline curve. So I'm going to just come here and I'm really going to focus on this data where I've got, the right number of wells that are driving things. And now I've got my oil decline curve here. So I can see, the first month is basically a cleanup period, and then this well has our average well comes on around 635 barrels a day, B factor of just over 1. All right, now how do I do that for gas? Well, I just basically say add fluid. I'm going to make a gas type curve. Once again, we're going to just repeat this analysis, and we're just going to very quickly do this here. all the same theories apply in terms of looking at our well count, in terms of, you know, building this process out. Okay, we've got that for gas now. Once again, we're going to do this for water. Okay, let's move our water curve in here and then zoom in a bit. And water here, once again, has a very strong hyperbolic decline due to flow back of frac fluids. And once again, I'm really focused on this early time data where we have more wells, not focused on it as much out here where the well count drops. That's why I'm less bothered about the misfit. All right, and so once I've done that, I now have a type curve for oil, gas, and water based on our average. Now, there are other ways you may want to think about this and slice and dice your data. So, you may say, hey, I don't want to work with an average. I want to work with a percentile. Well, hey, no problem. Let's create a new type curve. Let's call this a Niobrara P50 type curve. Okay, once we do that, we've created that P50. We just come down here and we select our well set. Now, even though I've called this well set Niobrara average, these are just the wells here. We're going to be using the P50 now for our aggregation. And what I'm going to do is I'm going to repeat that same style of analysis where I'm focusing on this early time data where I've got more wells. Okay, it's at now, my bold well, my highlighted one here is the P50. Once again, I'm going to do that for oil, gas, and water. So let's just real quickly, finish up our gas here. All right, we've got our gas, and now we're going to, once again, do this for water. And we'll just pull this in. Okay, let's get our water up here, and we have, okay, well, I actually just made a mistake here. I said we were doing that for our P50. I actually need to tell it to do the P50. So, hey, there we go, percentile 50. Okay, we can see there's been an update here. So now I need to come in and just modify that a little bit. And we can see that the P50 and the average were, of course, very close, as we would expect here. But there are some slight differences. All right, so let's say I wanted to now do this for one more percentile. Let's do something really different. Let's say we wanted to look at a lower percentile here. So I'm going to call this Niobrara P10. Come down here, percentile. We're going to look at the 10th percentile. We're going to select our well data set here. And now we can see, this is kind of our low expectation. So when we're using the term percentile here, we're using this to refer to the 10th percentile not in terms of our, 10th, the 10th as the top 10%, but the 10th as the bottom 10%. There's always some confusion about that in the oil and gas industry when people talk about P10s and P90s, but we're talking about it in kind of the mathematical sense here, even though maybe that's not the most common convention. All right, and here we can actually see that our P10 for our gas is quite a bit lower, so we're going to focus on getting that match here, and then we can do the same thing for water. Now, once we've done that, we've now got our our average, a P50, a P10 type curve that we have available. Before we go into applying that type curve, I'm going to jump back here to my average. Okay, we're going to look at this type curve one more time, and I want to talk about a few of the options that we have here that will affect your interpretation. So you'll see, first of all, by default, we have pad abandoned wells turn on. So, if a well starts producing and it goes offline after 3 years, we want to keep that in. So we want to keep those zeros in our production stream here to make sure that we're not throwing out bad wells, because that's a real well that failed and didn't do well. So we want to make sure we keep those in. We do have the option to compress empty periods here. This will make your wells look like they're performing a little bit better. It's a very subtle difference for this data set, but in some data sets it makes a much bigger difference. It's basically, are you looking at, calendar time here, or are you looking at, producing time? So that's what happens here with that empty period. And then we also have the ability to normalize. Probably the area where we see most of our customers doing this is normalizing by lateral length. So what we're doing here is we're showing the normalization per 1,000 foot of lateral, and we're saying, hey, we got to have a minimum lateral length of 500 foot here. And you'll notice that all of a sudden now we have a misfit on our type curves. So I want to show you, exactly what's going on here is we've basically rescaled everything. So now we're making that interpretation, per 1,000 foot of lateral. So that's why we have, of course, significantly lower numbers here. So, let's come in and do that. Now this is a way to help you understand, how much of the spread in your well is caused by having, substantially longer lateral lengths. So once we've done that, we've built our type curve. Now our type curve is per 1,000 foot of lateral. So we can say, hey, these wells are making, 80, the QI is 80 barrels per 1,000 foot of lateral. So it gives us an interesting new view. So now let's go apply these type curves. So what we do is we come back over to our decline curve graph, and let's look for wells that have a significantly shorter history. So I'm going to use my filters to find a well here, and let's say this data set's about a year old, so we're going to look at wells that were drilled after 2021 here. And okay, we've got a well like this, and of course you get an excellent fit to this well, but there's not a lot of data, so we don't actually know what should be going on out here. So this is where we can use our type curve, and we can come in and we can take, for example, that P50 type curve for each of them, and when we select that, we now see that it applies that P50 decline parameters out here to our well. We can see where it goes terminal, and then we can see where the economic cutoff is. Okay, so let's zoom back in here to our production. So that's using the P50. Let's say we wanted to use that lateral length normalized value. So we can take that one that we used, and what it'll do is it'll go in, it'll read our headers, so it'll understand how long that lateral length is, and then it'll scale that type curve to match that. And once we've done that, now we're using that type curve to drive our production forecast. All right, so that is where I'm going to cut it off here for this video. We're approaching 15 minutes here, but just a reminder, what it is we did here is we went through and we made multi-well type curves for our average P50 and a kind of a low-end well. And we did that based on a set of wells that we've filtered down to based on things like spud date, formation, cumulative production. We did a normalization by lateral length, and we explored some of the options about padding out wells and compressing our empty time periods. And then we came over and we applied that decline curve to a well with a short production history so we could understand how it was performing against expectations and what we expect our EUR to be for this well with respect to our oil, gas, and water phases. All right, hope this was useful. If you'd like to learn more, you can always get in touch with us at sales@danomics.com. Thank you.